Hello, everybody. I'm going to be talking about the Erlang formatter. Uh, Almost. But yeah. So imagine a situation when you're sitting down to your computer and you start to craft your artisanal code, right? Dotting the i's, carving every single letter, adding spaces when necessary, using your clicky keyboard and annoying everybody at the office, right? But nobody dares to tell you that you're annoying. And then somebody comes with a formatter and they produce the mass stamped code, right? Tear down everything from you and build something that looks everywhere the same and there's no spirit or nothing that goes for it. So yeah, that's what we're going to be talking about today. My name is Michal Muskala, and I'm a member of the WhatsApp Erlang team, where we're trying to improve Erlang for everybody and improve the tooling around it. So let's maybe start. What is a code formatter, right? So imagine you have this code. It's somewhere in OTP, right? And it has long lines. It has some awkward indentation here and there. It's not bad, but it's also has some issues. For example, if you change the handle response function name, right? You need to shift the whole block of the code to the right. And there are some other problems. So the formatter is something that takes code that looks like this and formats it in a uniform way, right? In this case, it would look like this after the formatting, right? So everything is kind of smoothed out and with consistent rules applied to all the places. So let's talk about why would you want to do that. Sorry. Yeah, let's talk about why would you want to do that. And formatters have a long history. They first started probably, I think, with some first papers in the 90s, when it was mostly about formatting code for papers and how you lay it out so it takes less space, so you could fit more of it in a scientific paper. But kind of nobody used formatters to apply to actual production code working on teams. With one exception, which was IDE-provided formatting, right? Especially this was popular in Java, and Emacs also had it going for it for a lot of different languages. And let's talk why people come up with this idea of formatting code, right? So people get annoyed by inconsistencies in their code. So if one person uses a different style for indentation, another person uses another style, you have a lot of clashes. It goes beyond just indentation and layout of the code. It also goes to naming and other things like that. And so people start probably enforcing the rules they come up with during code reviews. But they're still, from one team to another, those rules might differ. So then somebody comes up with the idea of having a style guide, right? And then once you have a style guide, but you still have to manually enforce it, right? During code review, during some other meetings, and it takes a lot of time. So somebody comes up with the idea. We have computers. Computers can do this for us. And they come up with a linter that tells you, instead of people telling you your code is wrong, you have computer telling you your code is wrong. So already an upgrade. But it's not really solving any problems, right? Because you still have to work on it yourself. You know where the problem is, but if the computer can tell you, here's the problem, maybe it can also fix it for you, right? So people are getting annoyed all the time with those tools that go halfway there, and that's basically how we arrive at formatters. So the way I like to look at formatters is that they are kind of automated linters, right? And so what I would like you to kind of, the premise I would like you to start from is that we want the goal for this, we want our code to be consistent and optimized for reading because we spend more time reading code than actually writing it. And this idea of adopting formatters happened multiple times in different communities. Probably started, I think it started being widely adopted and widely desirable tool with Go. And then it continued to other languages. Elixir got a formatter a couple years ago. Erlang, interestingly, Erlang also has a formatter in standard library that ships with OTP, but it has some problems dealing with macros and laying out other things. So we're going to be talking about those problems soon. So, yeah. So what are those use cases where the formatter helps the most, right? So you have a new team member that joins your team, and you want to help them out, right? You want to teach them the style guide, you want to teach them the rules. Instead of somebody helping them out, you have the tool to do this, right? You only need to look at what the tool does. It also helps tremendously when you're collaborating on open source projects, because with open source projects, you always the new team member, kind of, right? So you always need to learn those tools. But it also helps when different projects have similar style guides or even the same style between them, because you can much easier go from one project to another. There's also the use case that kind of I think comes up secondarily, which is kind of tedious manual reformatting. And I give you an example. Imagine you have this code, and it just fits under the line length limit, right, that you've set up. So everything's nice. But then you decide to change the name of the function from get to getAnno, for example, to make it more understandable. I'm not sure that achieved the goal, but let's assume it did. But now it exceeds the line length, right? So what would you have to do manually, right? You would go and go after the opening curly brace, hit enter, indent it, another enter, and align everything together. While with a code formatter, you can just hit save in your editor, and bam, it's formatted, right? So there's the formatter also, besides doing those things for people just joining the team and for helping with code review, it also actually helps writing the code, because you don't have to think about how to lay the code out. You just write the code, hit save, and it's there how it should look like. So we've decided to build a formatter for Erlang. And how hard could it be, right? There's formatter for all kinds of languages that exists. And there are a couple approaches you can take, but probably the simplest approach is to go through kind of those at least 4 big points, right? Which is to parse the code, then shape it, right, to the correct to the format that you want. Then to think about handling comments, which is one of the biggest hurdles in most languages, not Erlang. But not because comments in Erlang are easy, because other things are harder. And then also something that some formatters do but others don't, and it's kind of one of the decisions, is how to preserve the intention of the user. Do we want to preserve it? Do we don't want to? How much control over the final format you give to the original author of the code. So yeah, I alluded that Erlang has other challenges than comments, and obviously this challenge is macros, right? The problem with Erlang macros, well, let's say compared to Elixir macros, is that Erlang macros can be non-syntactic. What it means is that Erlang macros can hide part of the syntax that otherwise makes the syntax incorrect. And I have one example here. The top lines are not as important as the bottom lines with the try catch, right? And one thing you can notice is that after you have those macros with G stack trace and stack trace, there's no arrow at the end, right? How you would have normally. And this is the issue, right? Because the macros hide part of the syntactic structure of the code. And this is not some completely random example. This is actually example from an existing code base. And some other examples that I found this time in our code base, especially with records, is that people like to alias records, and they alias them in two different ways. So you can just hide the atom name inside of the macro, or have the atom name with the hash, pound sign, whatever you call it, in front of it, right? So the complexity of it grows significantly. So the approach you can take to handle macros, there are two approaches. You can either give up on the whole idea of parsing and go through basically the tokens one by one and create an ad hoc parser on your own just for the formatting. The other approach, and the approach that I took, is to basically pound hard enough on the parser until it can handle macros, or until it can handle all the macros that you want it to handle. Which for me was the benchmark was it can parse all of the WhatsApp source code and OTP source code. But actually, the main parser, the parser that ships with Erlang, and that was the starting base for my pounding, it has other issues. Right? For example, it represents those two things that look very different in source code with exactly the same AST. Right? And the problem is that if somebody wrote one or the other, there was probably a good reason for choosing one over the other. So ideally, we'd like to preserve that decision. There's also this other wonderful feature that Erlang has, which is implicit concatenation of strings. So whenever you have two strings side by side, they are concatenated by the parser. And this also happens inside of the parser, so the parser completely loses information what was the original string that it concatenated, right? And if somebody chose to use hex notation to write a byte in their string, they probably had a good reason to do that, right? And we want to preserve this information. And there's another problem, which is that the parser has imprecise location information. In most cases, when it only gives you line-by-line position information, that's fine. But that's not fine when you want to handle comments, because you want to locate the comments and insert them back into the syntax tree once you parsed it. So, and the parser, the location information had two issues. One, it was basically only tracked the first character when you ask the parser to give you column information. But then for compound terms, like for example function call, like remote function call, it gave you the location of the column, right? Which is not particularly useful if you want to understand it. And there are some more and more tiny elements in the parser when it drops some information that you might want, that was needed to preserve the original formatting or to correctly handle comments. So yes, let's talk a little bit more about algorithms. And here's the history is long, and it's most related to functional programming. Or rather, there's a lot of history with functional programming and layout algorithms expressed as algebras in languages like Haskell. So probably the most influential paper in this area is the design of a pretty printing library by John Hughes, and this is kind of the fundamental algorithm used by couple formatters. And then a prettier printer kind of simplified the approach, also producing some nicer results. And finally, the last paper adapted those two approaches that heavily relied on laziness in Haskell to use in strict languages, In this, in particular, was OCaml. And this last algorithm, I would say, is used very commonly today in many formatters, for example, in the Elixir formatter. But doing my research around those things, I found another paper, which I think was released 2 or now 3 years ago, which took a slightly different approach to formatting and promised giving better results. And that's the algorithm I decided to implement. The fundamental kind of issue that you have to deal when you design this algorithm is that you have a nested structure, right? You have the AST. So you can have one element nested into the other, nested into the other. And for each of them, you can have a couple ways to lay them out, right? So you can easily see how those cases start compounding into an exponential search area that will basically take forever to look for. So those papers, all those papers take different approaches to kind of handling this exponential search space, and we'll explore it a bit more. Okay, well, I'm still having slide subtitles everywhere to keep you on your toes. But yeah, let's say, so what is the kind of the flow of the algorithm? What is the things we want to build, right? So first we start with the source code, let's say this foo abc call, and then we parse it with the parser that we've managed hard, and we get AST, right, which is the symbolic representation of the code. Here the underscores represent some more complex data structure that hold annotations for all the AST nodes. So those annotations might be the precise location, might be the information whether there were comments or not besides. Also in our parser, we store information whether the thing was wrapped in parentheses, because, for example, inside of macros, it's important to preserve parentheses. It might change the meaning of the program. And then once you have this AST, you want to turn it into this algebra that represents your work. So in our case, we built a data structure like this. So we allow to lay the code in a couple ways. And there's like 3 main elements. Probably like analyzing this deeply doesn't make much of a difference. But there's choice that tells you can choose between two or more different layouts. There's sec, which is sequence. This means you lay things out one besides the other. And there's flush, which means you want to have a new line after the thing. And as I said, the naive approach to handling that, right, when you have choice inside of a choice inside of a choice, when you start to decide which one of these choices you want to take, it's an exponential approach. And in this case, it's the orange line. So it's not the one that goes up the fastest, but it's the second one. So it's something we definitely want to avoid. And the idea in this paper is that, let's say we have some example shapes we want to lay out side by side. Instead of tracking the precise shape that we want for kind of evaluation which of the layouts we might want to choose, we only track the general shape of the result, right? So we devise a metric saying what's the maximum length, what's the height, and what's the length of the last line, which is those elements are important for laying things out. And then whenever you have something bigger along those metrics, it will never, and you kind of lay it with some other element, right? If you have something bigger, it will always give you something bigger. So you can establish a partial order between different layouts, and kind of, instead of going through all the possible answers, you can throw away some of the answers early. Asymptotically, this doesn't improve the performance of the algorithm, but in practice, it's fast enough. So that's kind of the hand-wavy answer to the problem. It also helps tremendously that Erlang has relatively short documents. So Erlang has, in every function and every attribute, is completely separate from the rest of the file in Erlang. So we can go basically function by function instead of building a document for the whole file, like most languages have to. So this also helps. And once we have this algorithm, now we go into the space of like infinite choices. What we can do with our code, we can do a lot of different things, right? So we can do tabs versus spaces. We can do comma first style. Some people like that. We can, so to do decisions, kind of there's almost an infinite sea of possibilities. So we need to devise some principles, some ideas, how to guide us in making those choices, right? So here's like one example of like one classical example of the choices, right? How do you break function calls when it doesn't fit on the line, right? Do you go with the second or with the last approach? It's not really clear one is better from the other if you don't have kind of anything to compare them against, right? So that's kind of why I started also with this idea of having principles for the formatter to follow. And the first one is that consistency is the most important thing, right? And kind of the format you come up with in the end should be relatively close to the style that's already used. That's very hard because different people use different styles. But you can find some commonalities and common grounds, especially in the most fundamental choices. And one of the things is that if you do a good job with choosing the style and then choosing the format, everybody will be angry at you, right? Because it's ultimately a compromise, right? There's basically, if you do a good job, nobody will be fully satisfied, but nobody will be super angry, but somewhat angry, right? And there were some other principles. One of the important ones for me was that the formatter should be idempotent, right? If you format the code and format it again, it should give you the same thing. And this is actually not true about some formatters out there that are used and can be very frustrating for the user. And we also decided at some point of working on it that there's almost an infinite amount of code improvements the formatter could do, right? So like change how things are parenthesized or rewrite some literals to have them consistently, for example, dropping single quotes around atoms when it's not needed, and do some other things like that. We decided that the formatter should be limited to layout only changes, right? So it basically only shifts white space around, maybe comments a little bit to a slightly different place. But in general, that's it. It doesn't do code improvements. But the formatter is kind of the first step in this whole journey, right? So it's kind of another way to look at it. It's kind of an engine to later build other tools on top of it, right? In particular, code transformations. Once you have code laid out in a consistent and uniform style, you can automatically change it easily. So with that, we can build kind of a plugin. This is not here today, but it would be possible to have a more of a plugin approach to allow for different code improvement elements to be plugged into the formatter, and even possibly to allow language evolution with some automated fixes, right, that the formatter could do, similar to the tools in other languages. Like we have GoFix, we have RustFix that apply if a new language version of the language or even a library comes out and deprecates a function or deprecates some construct. You get an automated way to fix your code, and it still looks good. because you obviously can use regexes to do that, and it somewhat works, but then you also get maybe extremely long lines if you change your functions to extremely long names to add, for example, deprecated unsafe prefix to it. So those like automated tools help with this a lot. And there's obviously a very big question, right, when we start talking about formatters, which is preserving history, right? For many projects, it's very important to kind of understand why things are done the way they are. And hopefully, if your team is very responsible, they wrote good Git messages when they were working on the code, so you can go and look at the older code and understand why it is the way it is. And when you do the formatting, you kind of break this chain because you have one commit that shifts everything around. Fortunately, Git has an option. I think it's since Git 2.23, but one of the recent releases, where you can tell blame to ignore a particular commit or to jump over a commit. We're giving you blame information. And this is used successfully. I've seen it used successfully in some big code bases and big projects that adopted formatter. So this is one possible approach. Another approach that when you have your blame tool, most of them usually, especially GitHub, nowadays have a button when you look at blame to show you the previous one, right? So if you have some consistent way to tag all the reformatting commits, right, and show this in the blame tool, you can kind of easier see that you should jump over this particular commit to look at the actual original source. So where are we right now? So main elements are finished and the tool works, but I'm not satisfied with it yet. And before I can give it to other people, I need to be satisfied with it myself. That's kind of the deal. The way the integration path will go is that there will be a Rebar 3 plugin to use it. There will be also a standalone eScript for those that don't use Rebar and don't want to use it, and editor integrations for this save on, for this format on save feature, possibly others. It's possible from things we've talked with the OTP team, there is some interest in including a formatter with OTP, since we already have one, so having a better one wouldn't be a huge jump, and maybe even reformatting the OTP source code itself. Unfortunately, the code is not open sourced yet, but it will be soon, once I'm satisfied with the format it produces. And this is the priority. I will work on open sourcing it. I hope to have it by the conference. Unfortunately, it did not happen. I think it's a matter of weeks, maybe a month and a half. So yeah, this was my presentation about how Erlang is getting pretty. And I'm open for questions. Thank you.
First off, great presentation. You mentioned that you didn't take the document daughter approach and found that you could integrate your code instead. I'm a little bit curious about how that was. However, documents are very easy to implement, and I guess I'm curious about what trade-offs you experienced having possibly implemented both. Was there big performance improvements? Was it as easy to implement?
So actually, all of the languages that use one of those original papers have extensions to the algebras defined in them to handle some special cases.
Does that include Elixir?
Yes, this includes Elixir implementation. So they kind of, all of them had to think outside of the original format to achieve the layout they wanted. And this paper promises that the things it allows, the algebra it defines, meant that probably we wouldn't, at least we don't need those extensions right now. So it's kind of straight implementation from the paper. So that's one advantage. The other is it promises kind of more flexibility and better results. If that will materialize, that's something to see. But I think so far it was a good choice.
Sorry. But I mean, still, you get to hold the calm, and you get to command the room.
Things work better when they're turned on.
It's a small detail, that's an implementation feature.
I like holding it anyway.
Yeah, no, that's exactly the point. Work for everyone. Got any more questions? All right, Felipe. There you go.
So you said that it's not open yet. So you're still evaluating the possibility to see if you can apply it for different versions of Erlang, or if you're capable to run the format for a huge legacy code and stuff like that?
Yeah, so the thing is that right now the format it produces is correct. It handles everything, but it's sometimes ugly, right, still. So that's kind of what I want to iterate on, to make sure the code it produces, I like it, right? And then I can start talking with other people if they like it as well. Hopefully they do, but probably they won't. But that's kind of a future discussion. But before I can say to people, use this, I need to want to use this myself, kind of. So that's the limitation.
So RuboCop, the Ruby automatic formatter, has 1 million options, and Elixir has like 2. Where on the spectrum do you expect this formatter to fall in terms of configuration options?
As it is right now, it's closer to the Elixir one. It has 1 option, which is the line length, and that's it. I would want to keep as few options as possible. We'll see during the kind of adoption phase if this will be possible or not. But at least from my side, I will try to keep as little options as possible. Kind of. So.
Any questions? A hand was raised earlier. Okay. Any other questions? Okay, let's finish. Thank you.
Yeah, thank you.